Hello everyone and welcome back to this series of videos on the Solow growth model. Specifically in this video, we're going to move on from the capital evolution equation of the previous video. And we are going to define and explain what a steady state is, which is actually one of the main implications of the Solow growth model. In the previous video, we left off with an open question. So if we said that capital will continue to grow as long as investment is greater than the depreciation, then will capital grow forever? Will investment always be greater than depreciation? Well, following the assumptions of the Solow growth model that show that output has diminishing marginal productivity and everything else that we said previously, we can derive that the answer to this question is no, it won't. Actually, what will happen is that capital is going to reach something called the steady state. So what is a steady state? Well, a steady state is a state, of course, where the capital equals in all of the periods, in all of the, let's say, following periods. So in this specific case, like it's usually defined as capital tomorrow being equal to capital today, but then this would be equal to capital t plus 2, and so on and so forth. These t plus 3, t plus 4, whatever. Assuming, of course, that we don't change any parameter of our model. So if we want to give it a textbook definition, we can say that a steady state is a long-run equilibrium where the capital stock per worker, usually it's defined in terms of per worker capital stock, but it also, let's say that, yeah, let's focus on the per worker case, and output remain constant. So of course, if capital and output as well, but for now let's focus on the capital stock, is constant across periods, it means that its growth rate equals to 0. When does this happen? Well, since we said the capital accumulates if investment is greater than depreciation, this is going to reach the steady state when we have investment equals to depreciation. And in simple terms, when the new machines that we buy, so when the new capital equals the capital lost. Of course, if one machine breaks down and we replace it with a full new machine, then we are going to have the same number of total machine functioning. If for every machine that doesn't work anymore, we buy a new one. So how does this work? Well, let's do a numerical example, let's say, to properly see how this happens. Let's say we have a depreciation rate that is equal to 0.5. And what this means is that 50% of machines break every period. And let's say that every let's say new period, we buy 2 new machines. Here, actually, I called this savings rate, but it's not necessarily our savings rate because it's not a rate. Let's actually call this new investment. So initially, if we start in period T with 2 machines and we start applying the fact that we are going to buy 2 new machines, but however, half of the machines that we already have is going to break down. So we are going to have 1 machine abandoning us, but we're going to buy 2 new machines. So we're going to start with 2 machines and end with 3 machines, meaning that in the next period, T plus 1, we're going to have 3 machines operating. However, in t+1, the same parameters apply, meaning that 50% of the machines are going to break down. So we are going to have so here we had -1, here we have a -1.5 machine. So we're going to, let's say, cut out one machine and a half. So the numbers are mostly to show figuratively what is going on. So here we had 2 new machines, and here we're going to have 2 new machines as well, and here we're going to have 2 new machines as well, and so on and so forth. And however, now we are also adding 2 new machines to our total capital stock, meaning that if at the start of the period we had 3 machines, now we're going to have at the end of the period 1, 2, 3 and a half. So as you can see, our capital stock is growing, right? So here it grew by 1 machine, here it grew by half a machine. And we can continue this process onwards. So if we go with 3 machines and a half that we have now, 1, 2, and 3, and this is going to be half a machine. Of course, we have to delete half of 3 and a half, which is actually 1.75. So again, it's becoming a little bit tricky to do this visually, but let's say we are canceling 1, we are canceling a half, and let's say we are canceling 0.25. However, we are also adding 2 new machines. So when we started with 3.5, we are now left with 1, 2, 1, 2, 3, and here we have a 0.75 machine. And again, as you can see now, our capital stock increased by 0.25, which is less than the increase that we've seen previously. So we went from an increase of 1 machine to an increase of half a machine to an increase of 0.25 machines. And again, we can carry this even forward if we want, saying that we start with 1, 2, 3 machines, and let's say this is 0.75. We have to delete half of it. So we're going to take half of 3.75, which is -1.875. But again, remember, we are also adding 2. So we are canceling 1, we are canceling this, and we are canceling something like 0.125 of this machine, but we are also adding 2, meaning that we have 3.75 machines to start with, and we end up with 3.875. So again, the main takeaway of this demonstration is to show you that the increase in capital decreases. And if we were to continue this process for following periods, what would happen is that at some point, you will end up adding 2 machines, as we've done until now, but we will also be losing 2 machines due to depreciation. So if we go back here, as you can see, the number of machines that we are losing is gradually increasing, and eventually it's going to reach a -2, which is exactly equal to the +2. So, of course, if every period we end up if we end up having 4 machines at some point, and we lose 2 due to depreciation, which is the 50%, right? But we also add 2. This process is going to give us a stable capital stock for all of the subsequent periods. Because even if we delete 2 more, but we add 2 more, we are still having the same number of total machines. What this means is that we actually reached the steady state. We finally did it. So this is what steady state means that we have no growth in the capital stock. And in order to actually explain this concept further, there is a very good graphical representation of such concept that we are totally going to explore in the next video.